It says solve the proportion. Enter any solution as an integer or reduced fraction. Separate with commas if there is more than one solution. There's no solution, click no solution. All right. So basically we have two equal fractions. Let me just bring it over here where it got a little more room. So equals, yeah. So we've got 3x minus 6 over 9 and 5x minus 9 over 2. Okay. So we've got, this is called a proportion, which means two equal fractions. In the math science world, that's called a proportion. Two things are proportional. Two things are proportional, then they're equal fractions, is what that means. Okay, so how do we solve it? Well, to solve equal fractions, what we're going to do is, cross multiply, meaning I'm going to take this group right here and multiply with that. And I'm going to take this right here and multiply with that. I'm going to cross multiply. So I'll have 3x minus 6 times 2 equal to 9 times 5x minus 9. That's called cross multiplying. It's like cross canceling, except it's not canceling, it's multiplying. You cross multiply. And then, now hold on. I know that you might be thinking, wait, Mr. Heron, you're changing the rules on us. It'd be good if you were thinking this would be a good thought. You probably should be thinking right now, hey, wait a minute. We already learned the rules for how to handle equal signs with fractions, and it's not cross multiply. Where'd that come from? It's LCD over 1. Right, you're exactly right. What I want to show you is this is the same thing. It's just a little quicker. And here's why. Well, if you're thinking, wait a minute, didn't we learn previously to do LCD over 1 to both sides, all the terms on both sides? Exactly, you're right. This is actually the same effect. Let me show you. Let me show you real quick before we go on and finish it. Let me show you, because I want you to see that math is just following truth, and this is just another way to say the same thing, although it might seem different. What is the LCD? Well, it's going to be 9 times 2 over 1, right? You just take both denominators, multiply them together over 1. It's 18, but I'll just leave it as 9 times 2. Okay, and then what do you do with it? You go 9 times 2. That almost looks like a decimal, doesn't it? Yeah, I don't like the way that's looking. So you go 9 times 2 over 1 and 9 times 2 over 1, right? That's what we learned earlier when you have equal sign fractions. You multiply by the LCD of 1. Notice what will happen if you do that. The 9s will cancel. And what will we have here? 2 times 3x minus 6. That's what we got. Doesn't matter which side that 2's on. And then what will happen on the other side? The 2's will cancel. And what do we got? 9 times 5x minus 9. You see it's the same effect? Do you see in the end, it's the same thing as just multiplying by LCD over 1. You can just go diagonal, diagonal. Now, the other thing you might think is, well, that's easier then, Mr. Heron. Why didn't we do that all along? Well, it's only the same thing when you just have one fraction on each side. If we had other stuff, if we had this and we had like a +2 out here, like a third term, if we had a third item in the problem, instead of just one fraction on the left and one fraction on the right, if we had like a +2 or anything, any third term, then it would not be so simple. Then you would have to do the LCD over 1, because then it would be more complex and it would be different. So that's why we learned the LCD over 1 thing. In general, yes, that is how you always handle any fraction problem. But if you just have the simple situation where you just have one fraction on each side, two equal fractions, you can just go diagonal, diagonal, because that's the same thing as LCD over 1. It's just a little bit quicker in this particular situation. All right, enough with the background. I just want you to show the rules are consistent. We really are not changing the rules. We're just doing it a more convenient way. when there's just one fraction on each side, you can just go diagonal, diagonal. It's the same effect as LCD over 1. All right. And so then what do? You just go boom, boom. It would be 6x minus 12. You go boom and a boom. What's that going to be? 45x minus 81. And then how do you, so that's step 1 here. How do you handle it? Step 2, when you have x's on both sides. See, here's the wall. We put in the wall separation. See how we have x's on the left, x's on the right. What do we always do? X's both sides. We do the opposite of one of them to both sides. You always got to do the same thing to both sides, right? So I usually do the lower, so minus 6x to both sides like that. Boom, boom, boom. It's gone. Minus 12. What is this? 45 minus 6. It's 39, isn't it? Yeah. Okay, and then you just finish solving for x. Just wrap her up. Solve for x. So how do we solve here? For x, add the 81. And what do we got? Boom, boom. 9x minus s. Is that right? 69, 79. Yeah, it's just going to be an ugly answer, I think. Oops. By 39 on both sides. I think you can reduce that. I think if you divide, I think 3 goes into both those. That'll be what? Yeah, so you always have to reduce fractions, remember. 23 over 13. Do they want a fractional answer on this one? I think so. Let me double check. See, I'm going to go out to the homework system real quick. Look at number 1. See what they want. Yeah. Yeah, they'll just, I just put in a fraction answer. That's right. So that's our answer. So the answer is 23 over 13. That is the x. Just leave it like that. It can't reduce anymore. Notice I did reduce it at the very end, though. I divided top and bottom by 3. So you got to double check to see if it can be reduced at the end. You've got to reduce the fraction. So recapping then, how do you solve 2 equal fractions called a proportion? You just go diagonal, diagonal. It's the same effect as LCD over 1 in the simple situation where you just have one fraction on each side. It's quicker than LCD over 1. Then you just get this, and then you just multiply, and then you, when you have x's on opposite sides, you do the opposite of one of them to get rid of it. Then you just solve for x. Then don't forget to reduce your fraction at the very end. There we go.